We have shown you in the previous video how to take numbers that are written in scientific notation and convert them to standard form. Now we're going to do the opposite. Now we're going to take a look at numbers that are written in standard form, regular numbers. How do we put these in to scientific notation? So still remember the same thing. This is very important when we're putting things into scientific notation. When a number is written as the product of a factor and a power of a base 10, the factor must be between 1 and 10. What does that mean? There are 4 parts to scientific notation you have to remember, okay? There's a decimal out front. Let's just say 1.23. All right, everyone okay with that? We've got a decimal. We have to have a multiplication symbol. We always have to have a base of 10. And then there needs to be an exponent. So when you write scientific notation, you have to include those 4 parts. Everyone understand? You cannot put 1.23 to the third power. That's something completely different. Okay? So those are the 4 things we need when writing scientific notation. And what they're saying with this last sentence, okay, this decimal always has to be a decimal that's between 1 and 10. So when I'm moving my decimal, either left or right, I have to move it to such a place that when I'm moving my decimal point, I've got to move it so that I create a decimal or a number between 1 and 10. Let's take a look at example 3. I think you'll see what I mean. Example 3 is 3,725, 3,725,000. Now, where is my decimal point in this situation? If you can't see it, it means it's where? If you can't see the decimal point, where is it? At the end of the number. Good job, Cole. Okay? Now, I want to create a factor that is between 1 and 10. I want to create a decimal between 1 and 10. All right? So which way am I going to have to move my decimal to get there? I'm going to have to move it to the left. Okay? All right? So if I move it this far, then I have 3,725. Is that between 0? Is that between 1 and 10? If I move it a couple more, what about right there? I have 37.25. Is that between 1 and 10? No. If I move it one more, I've got 3.725. Is that between 1 and 10? Yeah. Yes, it is. Okay. So I have moved it 1, 2, 3, 4, 5, 6 times. My decimal point, the first part is going to be 3.725. The second part is, remember, it's multiplication. The third part is at a base of 10. Now, how far did I move it? My decimal or my exponent's going to be how far I moved it. So my exponent's going to be 6. The question is it positive or negative 6? Well, what kind of number did I start with? Was this a big number or a small number? It was a big number, so big numbers are associated with what kind of exponents? Positive exponents, okay? So my answer for this one is 3.725 times 10 to the 6th. Let's do another example. I've got 931,500,000. Okay? Now, my decimal point is here at the end. I'm going to move 1, 2, 3, 4, 5, 6, 7, 8 times. All right? If I move it right here, then my new decimal will be 9.315. All right? Now, I've got to multiply that by a base of 10, and I have to determine what my exponent was going to be. Well, I know that it's going to be 8 because I moved it 8 times. The question is positive or negative. Well, what kind of number did I start with? A really big number, which means my exponent is going to be what? Positive or negative? It's going to be positive. Okay? Positive. Remember, large numbers, Justin, positive exponent, right? Large numbers, positive exponent. So this is a large number. It's going to create a positive exponent. Correct. Tay just talked about small numbers and their negative exponents, and that's the example we're going to do right now. Example number 4, we have 0.000316. Would everyone agree that that's a small number? Yeah, very small. If someone gave you that much money, you wouldn't thank them for it because it's nothing. Okay? Now, before you even try to put this in scientific notation, I want you to tell me, is the exponent going to be positive or negative? It's going to be negative. Why is it going to be negative? Because this is a really small number, okay? Now I take this decimal point and I've got to move it 1, 2, 3, 4. And it's got to be right here. Because if I leave it here, I have 3.16. This is a number between 1 and 10. If I went one more, I would have 31.6. That's no good. If I went one less, I would have 0.316. That's no good. I need a number between 1 and 10. So I have 3.16. I'm multiplying by 10. I moved it 1, 2, 3, 4 times. And because it's a super small number, my exponent has to be negative. One more. Here we go. Not that one. This one. Tell your neighbor what you think the answer to this one would be. I want you to write that in scientific notation. How many people came up with 4.4 times 10 to the negative third power? Okay. Trey, do you understand this, or are you struggling a little bit? Just remember, it's always going to be times 10. So that's 2 parts that are very easy. Here's what we have to remember. Okay. Times 10, that's easy. This and this, got it. The only thing you have to remember for the decimal is it needs to be between 1 and 10. So if you move your decimal point and you rewrite your problem, and it's not a number between 1 and 10, you did it wrong. So that's easy to fix. And then the other thing is what the exponent is not a problem. The question is it positive or negative? And we can answer that by looking back at the original number and saying, is it a big number or a small number? Okay? All right. Let's try some on our own. You've got it at the top of page 53. Got it D, E, and F at the top of 53.